This is AP Calculus Lesson 10-2. We are on integral analysis. Okay, so what does standard V mean? Standard V is analyzing integrals instead of talking about the fundamental theorem of calculus.
Can we close the door, Mr. Sindel?
You may.
Will you close the door when you're...
All right, so we are on the second lesson out of the 3. If you were not here yesterday because you were taking your test, make sure that you have the notes from yesterday and the worksheet from yesterday. All right, so let's talk about some review. This was way, way long ago when we did our F prime and F double prime test. I want the short, easy definition. Where is F increasing? That's where F prime, all of these are going to be F prime because it's the F prime test. It's where F prime is
Greater than 0.
There it is, greater than 0. F decreasing. There it is, F prime is less than 0. Critical values. Yep, good job, Isabel. Or, not exactly. Or DNE, exactly. The reason for DNE is because sometimes it jumps down like this. We have to be careful of that. 4, F relative extrema.
Is that when it's sign change?
Yep, so this one is going to be, I can't really squeeze it in here, so I'm going to do it up here. F prime sign change. What is a relative extrema again? Can someone give us a conceptual idea of what that means? It's words to me right now. Can you describe with a picture with words? More words.
Bloop?
It's like bloop, okay.
Or slope is like slope is 0. So like, or like slope goes from being like that to being
Yeah, so that, yeah, exactly. So slope is 0 is a great,
like that.
Oh.
You know?
yeah, so it's where the slope is 0. So as Kaylin was, I'll draw it on here so that people in the video and all of us can see. So if you have something that looks like this, oh look, relative extrema there, and that's basically the only points. I guess you can sometimes have relative extrema at the end if the endpoint somehow is like that. I don't know. But yeah, so relative extrema is where there's an F prime sign change.
Sure.
All right, so, and yeah, on that picture, it went from a positive slope to a negative slope. That's why right here, that's a relative extrema. All right, oops, went back too far. All right, F minimum. What's the definition?
When it goes like from like a negative slope to a positive slope?
Negative to a positive. So this is my abbreviation. I like this better. I'm going to do the formal abbreviation for max. F prime for max is going to be positive to negative. But the formal way of doing that is F prime is positive, and it goes to an F prime being a negative. So those are 2 different ways of doing these. You can choose whichever one is easiest for you. I personally like this one, but if you're writing on the AP test or on my test, this right here is what I expect. And F double prime tests. So now we're dealing with F double primes. Concave up.
It means when there's a curve in the line and then the arrows go up.
Yeah, so you're thinking about something that looks like this. So this is concave up right here. What does it mean in terms of our notation over here?
Oh, F double prime is greater than 0.
Perfect.
Mr. Sindel,
Yes.
for F/max, I can do positive to a negative, right?
For your notes, yeah, you can say positive to a negative. But the problem is you need to either explicitly state on your AP exam that F prime is positive and goes to a negative, which is a lot more to write. So you'd have to say something like F prime is negative or positive and turns into positive. You'd have to write out that, or you could write out this right here. I'm teaching you the quicker way of writing it. If you don't like greater than or less than because we get confused, then you need to write it out in words.
Yeah, I like to write it out more.
All right. Let's get rid of that. All right, and then F concave down. Someone aside from Sophia. Sophia gave us number 7.
F double prime is less than 0.
Less than 0. And thank you, Carly. You're correct. And function inflection point. F double prime
Equals 0.
equals 0. No. But good guess.
What?
There it is, yeah.
Wait, why
Joy
did
has
you
it.
write it and tease me like
Yeah,
that?
that was You're like,
Just
You're
kidding.
like, yes.
Yes, no, yeah. So Joy has it. It's f double prime is a sign change.
Wait, doesn't it have to equal 0 for it to be a sign?
She makes a good point.
Not exactly,
Yeah, there's conversation.
because you have a possibility of it jumping around.
Oh.
So, for example, you're thinking on the graph of f prime. So let's actually look at a graph of f double prime. So you're thinking, oh, right there is an inflection point because it hits 0, it goes from a negative to a positive. What if I have a graph that looks like this? It changes sign, so it is an inflection point, but it doesn't go through 0.
Or what if it? Never mind.
Rosalie.
It like made sense in my head, but
Okay, couldn't verbalize it. Okay, so let's go ahead now and talk about types of integrals.
You, Mr. B?
I love being Mr. B. Sarah, would you shut up?
So we're really familiar with these first two types, but the third type is the one that we're really going to have to pay attention to. So the first type is indefinite. And I could say indefinite integral or definite integral. I'm just going to say indefinite. And number 2 is going to be the definite. And number 3,
Are
this
these gonna be graphs?
they're going to be graphs under here, yeah. So get ready to do stuff like this. And number 3 is going to be accumulation. All right, so we know indefinite. There's another name for indefinite integral. Do any of us know the name for indefinite integral?
general.
Infinity.
How about
Kind of. General is another word. I'll take that. That wasn't the one I was looking for, but you are correct. Starts with an ant. Antiderivative.
Hey,
Ant.
We went.
All right, so let's go ahead and make some graphs.
And she's like, no, like how is that antiderivative?
So, by the way, keep this area down here open. I know for you girls, it'll be easier because you have a page that goes on and on. But for me, I have to make sure that that space is clear as well.
how many pages of or how many slides of notes do we have after this one?
1.
Ow.
All right, so indefinite. So let's do the same. Well, let's try to do this. Oh, I have technology. It's going to be the same curve. Let's do the same curve in all of these if you can try. I know. Don't you wish you were cool like me?
Oh, sick burn. Sick burn. I was just gonna say that.
Yeah, I got.
All right, copy, paste. Right about there. Copy, paste. Right. Ah, there it goes. All right, so roughly the same function. They got shifted up and down a little bit. They had a vertical shift.
Wait, are they supposed to be shifted?
No, they're supposed to be the same. All right, so you have the same function, but depending on how you take the integral, it will be different. So let's talk about the indefinite integral. What is the area of an indefinite integral if this was the general curve? Would we know how to find the area?
You just draw a line down sides, right?
So I think you're thinking of definite, where you go like this, right?
Yeah.
So that's definite, but not indefinite. Indefinite doesn't have a beginning, doesn't have an end, therefore the area is infinite.
They kind of look the same.
And the way that we have the notation is the integral, or the antiderivative, of your function. So let's say that we were graphing, and each of these were the graphs of f prime, f prime, f prime, f prime. So the antiderivative of f prime is just antiderivative of f prime. We'll say of x dx.
It's okay. I know you don't want to kill me. Just said something.
All right, finite. So as Rosalie pointed out, finite, you're going to have a beginning and an end. So we'll say a beginning is A, an end is B. And you usually have, we'll do this in a different color, you'll have like a line right there, a line right there, and then you'll fill that in right here. So this is going to be finite. We'll actually be able to find a number. All right, I need some girl in here to tell me what is the integral. What is the notation going to be down here?
Yeah, I'm a man.
Is it like
Integral from A to B, f prime of x.
There it is.
Oh, calling me a man? That's the wrong way to put it.
So as Caitlin said, it's the same thing, but we have a beginning and an end for our integral. And finally, accumulation. You've done these before. I haven't officially named them, but accumulation have a beginning and no end. Accumulation have a beginning at A, and we don't know when they end.
So from A to infinity.
Careful, you almost have it. So it's the integral from A to something of f prime of x. Ooh, it's not f prime of x. Sorry. What was that, Joy? Yeah, any variable up here, exactly. So usually what we're going to do is we're going to do an x up here. And we're going to say that we have a function that defines this accumulation. This accumulation is defined by g of x. This accumulation is g of x, and it is defined by this integral from the beginning to x. Notice that this, let me point this out. Actually, I can use the highlighting here. So this x right here is the same as this x right here. If I plug in 2, this will be the antiderivative or the integral between a and 2. If I plug in 3 for g, it's the accumulation between a and 3.
My mind is blown. I just remember like doing this in like 7th grade.
Really?
no way?
And like it was like sums and you plugged in the numbers.
Oh, wow. Cool. Good
Wait,
7th grade
does
teacher.
anyone else remember that? Maybe I'm just crazy.
went to some really nice
All right. The difference here
She was with us
is
in
that this is
seventh
no
grade.
longer f prime of x because
Maybe not.
this x is very specific. I can't have the same x. It now needs to be a different variable. I just choose a different variable. Typically, it's going to be f of t.
Is it still f prime?
It should be f prime, yeah. f prime of t dt. This is important because I didn't make this distinction in our last unit, so I'm making it now. This variable on the inside has to be different than this variable on the outside. If they are the same, you have made a mistake. It's a minor mistake, granted. You might not lose points on the AP test. You'll lose points in my class. Make sure that these are different variables.
I have a question. What do we write in the area region? Like you have infinite.
It'll be finite depending on where you draw your B. So you could say your B could be here, you could be here, you could be here. We don't know where B could be. But it will be finite, depending on where B is.
I don't like how that word's it should be finite.
Finite. Yeah, exactly. Can I go to the next slide?
Yeah.
Yep.
All right, let's do the setup for this slide. So on this slide, I want to talk about the derivatives of accumulation. So the whole point of this lesson is to talk about this third type of function. All of the homework is number 3.
Bro, that's the one that I was like, sorry.
Yep. So this is going to be...
But isn't that the one that you got from 7th grade?
Well, no, it's like totally different, but I remember seeing the thing that was like the big S, and you plug in the numbers.
I
and
think I remember.
yeah, and Mr. P was like S for sum.
Yeah.
Like he's like, S for sum.
That is where the symbol comes from. S is for sum.
That's pretty crazy though.
S for sum. I was just
We've been talking about
All right, give yourself some room on the left here. We'll say g of some x is equal to, I'm just going to copy down what we had in our last one. It's going to be the integral between, give yourself some room between the equal sign and here. So give yourself some space right there. The integral between a and x of f of t dt.
Mr. Siddle, how many pages do you think these notes are going to take?
This is our last slide. We'll probably end right about there.
Okay, because I'm going to lose it.
Oh man, okay.
Only this much.
All right, so what I'm going to do now is I'm going to take the derivative of both sides. So I write that, I say d dx, d dx. Notice I'm taking the derivative with respect to x here. And what's going to happen? So I'm going to draw on the next line. So this is now just going to be dgx over dx. I'm just going to abbreviate that as g prime. That's way easier. G prime of x. We've taken the derivative of the left, and now we're going to take the derivative of the right. So I'm going to leave this as d dx.
Mr. Sindel,
Yes.
sorry, on the line above you, isn't it supposed to be f prime of t?
It is supposed to be f prime of t.
Do I get a point for that?
Yes, you do.
Yay!
I should have copied down the f prime as t as well.
Sorry.
Yeah, so log it in your extra credit tracker. Remind me to sign it sometime.
Guess what we did yesterday? Study group.
Nice.
Yeah.
Oh, I apologize, Sophia. You do not get it should be f because I need to talk about what happens when you go backwards from lowercase f.
You get a capital F?
You do get a capital
So
F.
you were oh, okay.
Yeah, so it shouldn't be the exact same problem. I misspoke. Yeah, so
I'll just erase it.
So have this in your side margin. Whenever you have the antiderivative of lowercase f, that turns into a capital F. And this is a general notation in all of calculus. Usually always on the AP calculus test, they will define this formally by saying something along the lines of capital F prime turns into F, which is the same thing here. It's just the reverse. So now instead of writing lowercase f, I'm going to use this definition right here. I'm using this definition, and I'm going to now say that this is going to be turned into capital F of t, but somehow I need to take into account a and x. So what am I going to do here? Evaluation bar, yes, from a to x. Good job, Joy. Evaluation bar from a to x.
Oh, and I keep the derivative sign there? Sorry, never mind. That was a dumb question.
Yeah, you do the d dx still. All we've done now, this blue right here corresponds to this blue right here. They changed verbatim.
So then you took the derivative. No, you took the antiderivative. Okay, you haven't taken. Okay, let me start. You haven't taken the derivative of the right hand side yet. You just took the antiderivative, and then now you're going to take the derivative.
Exactly, yes.
Okay.
All right, and I also need to analyze what is x and a. X is a what?
Just a variable.
Exactly, thank you. But what about a? Is a also a variable? What is a then?
You're starting.
A is a starting point, but more specifically, well, I guess that is even more specifically, but what type of thing is it? Is it a variable versus a, so I suppose a C?
Constant.
There it is.
I'm so glad I didn't say C.
And Kaylin is right, that is the constant where you start. So now I'm going to evaluate this thing. So I'm going to rewrite all of this right here, I'm going to rewrite. So it's going to be g prime of x is equal to, and I'll rewrite this, d dx. And now this is going to be a little bit advanced, so I'm going to do a giant square bracket here. This, when I evaluate, is going to be capital F of what?
A?
Capital F of, oh, that's not the first one.
X.
Yep, x goes first. And I'm going to subtract capital F of a. Perfect. All right. What I'm doing here, by the way, if I back up, I want to show you the shortcut for how to get from here, and then the shortcut is going to be right down here. What happens when I take the derivative of an accumulation function? What's the shortcut? I'm deriving what's happening right here. So what are we going to do here? We're going to distribute the derivative. So when we do that, we now get g prime of x is equal to, well, what's the derivative of capital F of x?
Are you leaving the other side of this blank for a reason, or can I go over there?
You can go over there. I'm going to maybe, no, I'm not going to do anything. Yeah, just
It's
go over there.
F of X.
Exactly. So using this definition right here, when I do capital F prime, when I do the derivative of capital F, as Sophia pointed out, this is now going to be lowercase f of x. And now capital F of a. If I evaluated that, what type of thing would I get? What will spit out there?
0?
It could be 0 if I put in 0, if the height was 0. We don't know exactly, but it will be some number. As Joy said, it was 0. It's a number. What's the derivative of a number? Derivative of a constant. 0.
Joy was smart. She thought ahead.
Yep. And therefore, we have our final line that g prime of x is equal to f of x. So here's your shortcut.
Just the way he said it.
So I'm going to use this space on the bottom right. So whenever I have g of x is equal to, we'll do the same thing. G of x is equal to the integral between a and x of f of t dt. G prime of x is now going to be, and you do want to write this stuff in green, this x gets plugged into that t. It is now going to be equal to f, I should go back to red here, f of x.
Oh.
This is the key thing that we need to take away from this lesson. Star this, do something important. That is the shortcut for whenever I have a derivative of an accumulation function. And remember, be careful here, because you still might have a dinner and a doubter when I'm taking the derivative.
What sucks, Mr. Sindel,
Yes.
is how you said that variable, the t, the f of t, but physically the t can never be the x, but at the same time, we just end up plugging it in.
You do
know
plug
what
it
I'm
in.
saying?
I do, yeah. So so you're saying that in the last slide I said, oh, these two need to be separate. X goes here, t goes here, and now all of a sudden I said, okay, now just put it in.
Yeah.
In order to put it in, you can't have it there to begin with, because then it's already there.
Yeah.
So yeah, just
It's okay.
it's a small point. And that's all I want to talk about for the notes.
And then, okay, so it would be f of x minus f of a, but we know that that's a constant. So-
Exactly.
Okay, that makes so much sense.
So go ahead and write your summaries, and I'm going to do 2 homework problems when we return. All right, we are back. This is going to be the homework, so we're on number 1 right now. Here is a graph of f. Notice it's not a graph of f prime, just a graph of f, and we define this accumulation function with g of x, just like we did in our notes, aside from our starting point now is 0 instead of a. So I need to find all of the CVs, all of this stuff on g. All of these are g. So in order to find all of these are going to be the g prime and g double prime. So I need to find g prime of x, and I need to find g double prime of x. To use, so concave up, concave down, and IPs, those are the second derivative. All of these are the first derivative. So to find the first derivative, this is going to be equal to what? G prime of x is equal to what?
Slope?
I want something, you're going to manipulate
Oh,
this
sorry.
using your notes.
Wouldn't be
F of x.
X?
F of x, yes, is correct. Which means, are we looking at height, slope, concavity? What are we looking for right here?
Slope.
No. This is a graph of f.
Height.
Height. Bless you.
Then wouldn't g of x be height? Doesn't it always start with height?
If we had a graph of g, then it would be graph of height. But notice that we're saying g prime now means we're looking at height of this graph. Now g double prime, bless you,
F prime of
Thank
x.
you.
is just f prime of x, which means we're looking at
Slope.
slope.
Everything makes sense.
Oh, I get it. Okay, gotcha.
All right, so for CVs, the definition of CV, it's where g prime is equal to 0 or d and e.
Or D.
So therefore, the height is 0 or d and e where?
At 4.
At what equals 4?
G.
At x equals
Oh.
4. Where else is it 0?
6.
6. And
0.
and 0. There they are.
I don't know, like the order we went in there.
Start in the middle.
All right, where is g increasing?
I don't think it is. 6.
From 0 to 4.
From 0 to 4. That is correct. Why?
Because there's a positive slope.
Nope.
The height is
The
positive.
height is positive, yes. Remember, g prime is what we're looking for. G prime needs to be greater than 0, which means height needs to be greater than 0. Height is greater than 0 between 0 and 4. And another way of writing this is between 0, x, and 4. Okay, g decreasing on
4 to 6.
4 to 6. And another way of writing that is not between 0, between 4 and x and 6. By the way, for the AP graders, they don't care if these are square brackets, if these are greater than or equal to. You're not going to lose points for that, as far as I know. But the alligators do need to be facing the right direction if you use those. The inequalities, more specifically. Okay, relative extrema. All of the relative extrema exist at what x coordinates? 4. Why?
Because it goes from a positive to a negative.
So you are defining a maximum.
It's a sign change.
It's a sign change. That's what gives us this one. What about the minimum? What is the definition of minimum again?
Negative 2. Or no, subscribe to that.
There's none. There's no.
Yes, but I need a definition.
Oh. A negative to a positive.
Negative to a positive. So there are none. This is a relative maximum because it went from a positive to a negative at this point 4. And then concave up. Now we're doing the second derivative test. Now we're looking at slopes.
X equals 5. Sorry, I know it's supposed to be an interval. 4 to 6.
4 to 6 is not quite right. We're looking at slopes. Where's the slope
Oh,
positive?
From 1
0
or 0 to 2.
0 to 2
5 to 6.
and 5 to 6. This is how I'd like you to write this. And then the other way of writing this is between 0 and 2 and between 5 and 6. I know there's not very much room to write it on your papers, so you'll have to squish it in. I had to squish it in on my paper as well. You're not alone. It's just I have a lot of free space here now. All right, concave down. Negative slope.
No, 2 to 5.
2 to 5. The slope is negative between 2 and 5. And another way of writing that is between 2x and 5. An inflection point. Before you give it to me, what's the definition of an inflection point without looking at the top of your papers? Yep, slope, sign change, I guess, for this one. So it's the second derivative sign change. So it's the slope sign change, and there's a sign change where?
2 and 5.
Yep, at x equals 2 and 5, because it was a positive slope and then it changed to a negative slope at this point 2. It was a negative slope, it turned to a positive slope at this point 5. Good job. So that was number 1. We're going to skip number 2 because you probably can do that now. And let's go to number 3 on the very back. All right, so number 3. This guy can be a little bit challenging. So they gave us a function of g. It's asking about increasing and decreasing, so we need to look at the f prime, or g prime in this case. So g prime is going to be equal to what? This is a little bit tricky. I don't want you to yell it out if you know it. If you know it, just write it down and continue working on this. But what is g prime in this case? Write it down. All right, quiet raised hand if you found g prime. Only 2 people found g prime?
What do you mean by like finding it?
Find the equation for g prime. All right, Joy, give it to us.
F of x plus 5?
Close. So this plus 5, when I take the derivative, that will go to 0. Yeah, so you're just left with this, and then we know how to take the derivative of that. That's similar to our first question where you just take it equal to f of x. Yeah, so g prime of x is just equal to f of x because the 5 canceled out.
Oh, and then you get your whole like capital F of 6. Or never mind.
Yeah, you don't have to rederive it. You just can use a shortcut. Therefore, we're looking at what? Height, slope, concavity? Height. And notice that eventually it does ask about an inflection point down in part D, so we might as well just find g double prime of x right now. That should be equal to f prime of x, which is slope.
What is that?
All right, on what intervals is g decreasing? So on these, let's answer with complete sentences. G is decreasing. On What?
Oh,
Negative 3 to 0. Well, let's let someone else get the second one. But I think you can get it and write down and go on to part B.
12 to 15.
And 12 to 15. Thank you, Joy and Kaylin. Okay, but we're not done. It says justify your answer. So on all of number 3, on all of number 4, the way that you justify your answer, you'll say because, and then you'll literally use a definition from our very top here. You use one of these as your explanation. That's all you have to do. So, because of what?
Maybe
Careful. We have to use something with G.
G prime is less than 0.
Because G prime is less than 0. There it is. And if you want to be, so you'll get full points for saying that, but I'm going to add some extra stuff also
Mr. Sandel,
on that interval. Yes.
what if I put and instead of that, like, you thingy?
That's fine. This is just a little bit more formal.
Okay.
All right, part B. We're just writing a complete sentence. Where is it concave down? G is concave down.
Hopefully, you keep moving your feet.
And it's going to be an interval. Where is it concave down? So Sophia and Joy are killing it, so you guys should be able to get it on your own, I think. Let's give someone else a chance. And Kaylin answered last time too, so it's between Isabel, Carly, and Rosalie. I want to hear from one of you three.
Okay, from 6 to 15.
From 6 to 15. Why?
Because the slope is negative. Or because G double prime is less than 0.
Perfect, yeah. And if you want to be more specific, what?
On the interval.
Exactly. Thank you, Isabel.
You're welcome. It's always that response.
If you put
I'm writing it in green because it's not needed for my class or the test. It just makes it sound really nice. All right. Part C. There's a lot of things we need to find. We need to find first extremum, then max, then min. So there's 3 things, 3 sentences that we need to write. So G has a relative extremum
Okay.
at x equals where?
at 0,
And
12.
perfect. Why?
Because F prime has a sign change.
Because be careful. It's not F. We're dealing with this letter here.
So G.
Oh, G.
G
F
prime
sign change.
sign change.
And we couldn't say equal to 0? Just wondering.
So that's not the definition, is it?
It's always this thing that gets us is like.
Yeah, you have to use
equal
this.
0, it's a sign change.
It's not equal to 0. It's a sign change. Exactly.
If it was a CV, though, we could do.
Yep. If it's a CV, that's your explanation. It's going to be it's D&E or not or 0. And then you could say at that point, but I ran out of room here in green. G has a relative max. We don't have to say maximum. Just say max at x equals where?
Was it 12?
It is 12. Why?
Because G prime goes from a positive to a negative.
G prime.
How you say
Yep.
that?
So from positive to negative. So the way that you have to state this in your homework on the test, on the AP test, is G prime is greater than 0, and it turns into G prime is less than 0.
So you can't say because it goes from a positive to a negative?
If you say if G prime goes from a positive to a negative, that is also fine. But you have to say G prime and you have to say positive and negative. This is the quicker way of writing it. And then finally, G has a relative min at where? Someone new. We'll give this to Isabel. She did
Maybe
give a
negative 3.
not quite at negative 3. Because negative 3, there's no sign change. At 1?
None.
There is one. So we got this relative extrema. The only relative extrema left
So it'd be 0.
is there. So why is it 0?
Because G prime
Careful, it doesn't go from positive to negative. That was the maximum.
Wait, what? It goes from negative to a positive.
Yes, from a negative to a positive. So the quick way of saying that is G prime is less than 0, and then it goes to G prime greater than 0. Good job, Isabel.
Oh, thanks.
And finally, we have part D. I think I can squeeze this in here. So G has a point of inflection. I'm just copying down how they say it. They say point of inflection, I'll say point of inflection.
If we called it an IP point, wouldn't that be like point of inflection point?
It would be, yeah. It's like ATM machine. Automatic teller machine.
Oh.
At
And everyone says ATM machine.
Yeah, like, are you gonna go to the ATM machine? No one ever says. That's so weird.
Yeah, that's the
Well, I say, are you going to the ATM?
Yeah, but
Yeah, but people.
do
So Joy, where's the point of inflection?
D.
I feel like there's a lot.
At 6,
Yeah,
yes. And what's your reasoning?
Yeah, me too.
Isn't it G double prime?
Yeah.
Something with G
Sign
double
change.
prime. Yeah, G double prime sign change. Perfect, and that's number 3. Therefore, you know how to do number 4. I've done half of the homework with you girls. I think you should be good from here. Do you guys want to, or girls want to say goodbye?